Hi. This is our third video for linear inequalities in one variable. This time, our focus is on solving linear radical inequalities. Okay, before we start solving radical inequalities, let us have first um, discuss a bit the steps in solving linear radical inequalities. So the first step is since the radicand of the inequality must be greater than or equal to 0, first solve the radicand to identify the values of x, which the left side of the inequality is defined. Okay, now let's discuss this one, the first step. So the radicand is the number inside your radical symbol. So let's say you have like square root of 5. Okay, so 5 here is your radicand. Okay. Now, take note that the focus of our lesson is only on square roots, okay? And whenever we have square roots, your radicand should always be positive, okay? So we avoid negative values for our radicand. So the first step is to find the values of x, which will make your radicand greater than or equal to 0. Okay, now after we solve that, the second step will be to solve the original inequality. So let us apply these two steps. Let's have some examples. Okay, let's solve the following radical inequalities. So the first one is 2 plus square root of 4x minus 4 is less than or equal to 6. Okay, so recall that from the steps that we have discussed a while ago, the first thing you need to do is to find the restrictions on the value of your radicand. So your radicand again should have a value that is greater than or equal to 0. So from this given inequalities, your radicand is 4x minus 4. So let's copy that. 4x minus 4. So again, your radicand should be greater than or equal to 0. So let us solve for the x. That would make your radicand be greater than or equal to 0. So let's transpose negative 4 to the other side. So this will become positive 4. Divide both sides by 4. So we can have the value of x, which is x is greater than equal to 1. So now we have our first inequality. Now the second step is to solve the whole radical inequality. So let's solve it. Now your first step is to always isolate your uh, radical. So here we will leave square root of 4x minus 4 on this side, and we will transpose 2 to the other side. So we will have now 4x minus 4 is less than or equal to 6 transpose 2 minus 2, and that is 4. Okay, now for us to cancel out our radical, here we will square both sides. So let's square that. So now we can cancel out your radical, and we will only have 4x minus 4 is less than or equal to 4 square is 16. So solve further, move transpose negative 4 to the other side. You will have 4x is less than or equal to 16 plus 4, that is 20. Now divide both sides by 4. So x is less than equal to 20 divided by 4, which is 5. So now we have here two inequalities. Okay, the first one is x is less than or equal to 5. Okay, and the other one is x is greater than equal to 1. Now this is not the final answer yet. Okay, so to get your final answer, you need to find the values of x that is common to your two inequalities. Now to help you do that, you can graph your inequalities on your number line. And then from that, you can look for the overlapping parts, and that will be your final answer. So let's show these two inequalities on this number line. So let's have x is less than equal to 5. So let's find 5 here. So this is here 5, and it's less than or equal to. So, oops. And then less than or equal to, so your arrow should be to the left. And then we have x is greater than or equal to 1. Greater than or equal to 1. Let me change the color. Okay, so greater than or equal to 1. So let us draw first a dot on 1. So it's greater than, so your arrow should be to the right. Okay. Now, for us to find your final answer, again, find the overlapping parts of your inequalities. And by looking at it, they overlap on this area. Okay. So when we write the final answer, we have learned already how to write compound inequalities. So let's write an compound inequalities equivalent to this graph. Okay. So our answer is your x, and then let's write here 1 and 5. So your x should be greater than or equal to 1, but is less than or equal to 5. Okay, that's it. Okay, let's have the second example. Square root of 2x minus 3 plus 3 is greater than 5. So again, let us find first the resection on the values of your radicand. So your radicand here is 2x minus 3. So 2x minus 3 again should be greater than or equal to 0. So let's solve for x, transpose negative 3 to the other side, so that will become positive 3. Divide both sides by 2, so your x is greater than or equal to 3 over 2 or 1.5. Next is to solve the whole inequality. So let us isolate first your radical. So we will transpose 2x minus, we will transpose 3 to the other side. So if we do that, we will have 5 minus 3, okay, which is 2. So let's just go straight writing that. Okay, now to cancel out your square root here, we will square both sides. So we'll only have 2x minus 3 now is greater than 4. Okay, and then after that, let's solve for x, transpose negative 3 to the other side. So that would be 4 plus 3, which is 7. Divide both sides by 2. You will have x is greater than 7 over 2, which is the same as 3.5. So again, to guide you in finding your final answer, let's show these two inequalities on a number line. So you have x is greater than or equal to, let's do this one, 1.5. So let's get 1.5. So middle of 1 and 2 is greater than or equal. So let's have it. It's around here. So greater than, so should be to the right. Okay. Next, we have for the second one, this, we have x is greater than 7 over 2, which is 3.5. So middle of 3 and 4. Oh, it should be not a solid dot. Let me erase that. Okay, and it is greater than, so it's also to the right. Okay, so now the goal is to find the overlapping parts of the two inequalities. So as you can see that they start to overlap at 3.5. This part that shaded. So from this part, okay, continuously there, they will overlap. So your final answer should be that your x is greater than 3.5. Again, why? Because they started to overlap at 3.5 and so on. Okay, last example. So we have 3 square root of x minus 1 minus 2 is less than 7. So again, let's solve first for your radicand, restriction for your radicand. So our radicand is x minus 1, and it must be greater than or equal 0. So your x should be transpose negative 1 to the other side. That should be positive 1. So your x should be greater than or equal to 1. Next, let's solve the whole radical inequality. Let's transpose first negative 2 to the other side. So this would be 7. Negative 2 will become positive 2. So 7 plus 2 is 9. Now we have a 3 here. So we need to divide both sides by 3. So if we do that, we will have square root of x minus 1 is less than 3. Then again, square both sides so we can cancel out our square root. So now we will have x minus 1 is less than 9. Then we have x is less than transpose negative 1 to the other side. That would be plus 1. So 9 plus 1 is 10. So our two inequalities are x is less than 10, and the other one is x is greater than equal to 1. So let's plot them. So we have x is greater than equal to 1. So let's find 1. So it's here. So it's a solid dot because it's greater than or equal. And again, the arrow is to the right since it's greater than. You need to make it longer since the other number is 10. And then we have a 10, right? So let's, oh, it's an open one. Okay, and it's less than, so your arrow should be to the left. So it's difficult to draw a straight line. Okay. So again, look for the overlapping parts. So as you can see, our answer should be from 1 to less than 10. So when we write our final answer, it's a compound inequality. So we have x here, 1, and then 10. So your x should be greater than or equal to 1 or less than 10. Okay, so that's it for our lesson for today. I hope you learned something. There's still more videos about this topic, so I hope you're going to watch it also. Thank you for watching. Bye.